Imagine a restaurant with one waiter handling 200 tables. That waiter will collapse. Now imagine 5 waiters with a host stand directing guests to whoever is free. That is load balancing. The host stand is the load balancer. It does not serve food, it just decides who handles each guest. In Azure, your servers are the waiters, and the load balancer is the host stand. Without it, one server failure takes down your entire application. Here is what actually happens. Your user types in your website URL. DNS turns that into an IP address. But that IP belongs to the load balancer, not any individual server. The load balancer receives the request, checks which backend servers are healthy, picks one using a routing algorithm like round robin or least connections, and forwards the request there. The server processes it and responds back. The user has no idea which server handled them. This is the basic pattern every Azure load balancing service follows. They just do it at different layers and scopes. Azure Load Balancer is the simplest, fastest option. It operates at layer 4, the transport layer. That means it sees IP addresses and port numbers, but it cannot look inside the request. It does not know if you are requesting /login or /checkout. It just sees a TCP connection on port 443 and sends it somewhere. This makes it incredibly fast. Use it when you do not need content-based routing. For example, balancing traffic across database replicas, gaming servers, or internal microservices that talk to each other. Think of it as a dumb but extremely fast traffic splitter. If you need to route based on URL paths or headers, this is not the right choice. Application Gateway is the smart load balancer. It operates at layer 7, the application layer. It actually opens up the HTTP request and reads it. So you can say send all requests to /API to my backend pool, send /images to my CDN, and send /admin to a separate lockdown server. It also includes a web application firewall, WAF, which blocks SQL injection, cross-site scripting, and other common attacks automatically. Plus it handles SSL termination, meaning your backend servers do not need to deal with encryption overhead. Use this whenever you are load balancing a web application and need routing intelligence or security filtering. The trade-off is it costs more and has slightly higher latency than the basic load balancer. Traffic Manager is fundamentally different. It does not touch your actual traffic at all. It works at the DNS level. When a user's browser asks where is app.contoso.com, Traffic Manager responds with the IP address of the best region. Maybe the closest one geographically, or the one with lowest latency. After that, Traffic Manager steps out. The actual request goes directly to the server. This means it is great for global routing across regions, but it has a limitation. DNS caching means failover is not instant. It can take 30 seconds to several minutes depending on TTL settings. Use it when you have the same app deployed in multiple Azure regions and you want users automatically routed to the best one. Azure Front Door is the premium option for global web applications. Unlike Traffic Manager, which only handles DNS, Front Door actually proxies your traffic through Microsoft's global edge network, over 190 points of presence worldwide. It inspects requests at layer 7, so it can route based on URL paths, cache static content at the edge like a CDN, apply WAF rules, and handle SSL, all before traffic even reaches your backend servers. The big advantage over Traffic Manager is that failover is instant because Front Door controls the actual connection, not just DNS. The trade-off is cost. Use Front Door when you have a globally distributed web app and you need the combination of performance, security, and instant failover. It is essentially application gateway but operating globally instead of in one region. Here is your decision tree. Ask these questions in order. First, is this internal traffic between services, or is it non-HTTP like database connections or gaming? Use Azure Load Balancer. Second, is this a web application in a single region that needs smart routing or WAF? Use Application Gateway. Third, do you have the same app in multiple regions and need global routing? If it is HTTP and you want instant failover plus security, use Front Door. If it is any protocol and you can tolerate DNS speed failover, use Traffic Manager. And here is the key insight most people miss. These are not mutually exclusive. A production architecture often uses Front Door at the global layer routing to application gateways in each region, which then balance across VMS behind Azure Load Balancers. They stack. Let us put it all together with a real scenario. You are running a global e-commerce site deployed in US East, Europe West, and Southeast Asia. Azure Front Door sits at the edge. It caches your product images, blocks malicious requests with WAF, and routes each user to the nearest healthy region. Inside each region, Application Gateway receives the traffic and routes based on URL path. API calls go to your compute pool, static assets go to blob storage. Your backend microservices, order service, inventory service, payment service, talk to each other through internal Azure Load Balancers. 3 different load balancing services, each doing what it does best, at the right layer. This is how production architectures actually work. Let me save you from the mistakes I see every week. Number 1. People use Azure Load Balancer for their web app because it is cheaper, then realize they cannot route by URL. They end up rebuilding with Application Gateway. Just start with App Gateway for any web workload. Number 2. People expect Traffic Manager to fail over instantly, but DNS caching means users keep hitting the dead region for minutes. If you need instant failover for HTTP, use Front Door. Number 3, and this is the most common. People deploy a load balancer, add their servers, but never configure health probes properly. If the health probe is not checking a meaningful endpoint, your load balancer will happily send traffic to a crashed server. Always probe a real health endpoint, not just a TCP port. Set your probe interval to 5 to 10 seconds. And always use standard SKU. Basic has no slot and limited features. It is not production grade. To wrap up, here is your cheat sheet. Azure Load Balancer. Layer 4, Regional Scope, best for internal and non-HTTP traffic. Application Gateway. Layer 7, Regional Scope, best for web applications with WAF and URL routing. Traffic Manager. DNS level, Global Scope, best for multi-region routing with any protocol. Azure Front Door. Layer 7, Global Scope, best for global web apps with instant failover, CDN, and WAF. Choose based on 3 factors. What protocol are you using? What is the geographic scope? And how fast do you need failover? Get those 3 answers and the right service is obvious. Thanks for watching.